Welcome Math 107 students to the demo for Lesson 8, where we work with complex numbers and we look at solving quadratic equations with non-real solutions. So the first part of this demo is to talk about a number system called the complex number system. And the complex number system was needed, for example, to try to solve an equation that would look like this: x squared plus 1 equals 0. So if we were trying to solve that equation using the quadratic formula, we would see that a is 1, b equals 0, since we don't have a middle term here. If we wanted to write the middle term in so you could see it, it would be 0 times x, which is 0, and c is 1. So if we put a is 1 into this formula and b is 0 and c is 1, and we start to simplify our quadratic formula all the way across, we would end up with the answer plus or minus the square root of -1. Well, there's no real number that defines that number, the positive square root of -1 or the negative square root of -1. Because we know that in the real number system, you have to take the square root of a non-negative number, 0 or any positive real number. So if I take this equation, x squared plus 1 equals 0, and I subtract 1 from both sides, then I get this equivalent equation. And this equation can be simplified using the square root property we discussed in our last lesson to x equals plus or minus the square root of -1. So regardless of which way we look at this solution, we don't know what to do at this point. So mathematicians decided to invent a new number system called the complex number system that will provide us a solution to this equation and other equations like it. Are you ready for the definition of the square root of -1? Here is our definition. Again, this is a definition. It's not something that you're going to feel intuitively. The definition is the square root of a negative number. The letter I is the symbol we use to denote the square root of -1. So I equals the square root of -1. So if we go back and look at our solution to that first quadratic equation, x squared plus 1 equals 0, or the equivalent equation, x squared equals -1, we now can replace the square root of -1 with I. So we would say that the answer, or the two solutions to that equation, are plus I and minus I, or negative I. So if we were to write the solution set, we put our smaller value first and our larger value second. So this would be the solution set. This will help you out with your homework. So you have to write your answers as solution sets. So let's do a little bit of work with negative numbers that appear under the radical sign. I will leave some of the arithmetic operations like adding, subtracting, multiplying complex numbers for your class activity. So let's work a little bit with this. When solving quadratic equations that do not cross the x-axis, we will use the following property often. If k is a positive real number, then the square root of the opposite of k can be written as the square root of -1 times the square root of k. Now remember, k is a positive real number, so this square root exists in our real number system. And we replace the square root of -1 with I. So our answer would be I times the square root of k, or you could write the square root of k times I. Typically, we put the I in front, so there's no confusion as to the fact. In this case, someone might say, well, is the I under the radical or not? And it isn't. So you have to be very careful when you write it to the right that it's outside of the radical symbol. So let's take a look at applying this property here to this first problem. So the square root of negative 49 can be written as the square root of negative 1 times 49. And we can rewrite that as the square root of negative 1 times the square root of 49. And that's I times the square root, of 49. I'm going to just simplify that right now. The square root of 49 is 7. Okay. So you can write it as I times 7 or 7 times I. So it looks almost like the square root of 49, doesn't it? 7, but it's got that little I attached as a factor. That's really important. Okay, so let me show you how you would check this. You can check the answer to any square root problem by squaring your answer. So if you were asked to square 7I, you would get 7 squared times I squared, which is 49 times I squared. Oops, we haven't defined what I square is yet. So let's go over to D and see what that would be. So I square is the square root of negative 1 squared. And if we square a square root, these are inverse properties. So what happens? The square and the square root will undo each other and we get a negative 1. So I square is defined to be negative 1. So if I were checking my answer here back to the 7I square, I get 7 squared times I square, which is 49 times I square, which is 49 times negative 1, which gives me negative 45. So I know I did my problem correctly. So for the purposes of this course, you only need to know the definition of these two numbers. I is the square root of negative 1 and I square equals negative 1. Okay, let's take a look at the second radical here. This radical can be rewritten as the square root of negative 1 times 8, which can be rewritten as the square root of negative 1 times the square root of 8, which can be written as I times the square root of 4 times the square root of 2. And the square root of 4 is 2. So I'm going to call this 2I times the square root of 2. I could have said I times 2 times the square root of 2 also. But we usually write the 2 in front of the I and then the radical to the right. Again, these are both equivalent, so any way you want to write it, because multiplication is commutative, so either of these is fine. All right, so I want to give myself a little bit of room here, so I'm going to do some erasing for a little bit here. Let's, I could maybe, yeah, I'll just erase this. All right, so let's take a look at C. You should recognize C as the part of the quadratic formula, right? It's the solution to the quadratic formula for x. So we're not solving anything here. We're just trying to simplify this expression right here. How would we simplify this expression? So let's just take a look at each part. Negative 2, there's nothing to do. Plus or minus. Let's simplify 2 squared minus 4 times 1 times 3. So we get 4 minus 12 in the numerator all over 2. So this equals negative 2 plus or minus the square root of negative 8 all over 2. Well, we just found out what the square root of negative 8 was. We just saw that the square root of negative 8 is 2I times the square root of 2. So let's replace that, square root of negative 8, with 2I times the square root of 2 all over 2. So we're almost done. we have to ask ourselves, is there a way to simplify this? And there's two approaches you can take. You can either factor out a common factor all the way around. For example, if you pulled a 2 out of the numerator, you would have -1 plus or minus I times the square root of 2 all over 2. And now you have a 1, form of 1. That would reduce this if you divided this out. And then your solution, not your solution, this is just a simplification, would be -1 plus or minus I square roots of 2 all over 1. So you can just leave it like this. Okay? So one way is to factor out a common factor that appears in the numerator and denominator and then reduce your fraction. Another approach is to recognize that this is a single fraction. And to get this fraction, I look in my numerator and I see that I had to add 2 fractions and subtract 2 fractions. And I know that when I add and subtract fractions, that I had to have a common denominator. So both of the pieces in the numerator, we call those pieces terms. Both of those terms had to have 2 as its denominator. So you could break this up to be -2 over 2, add or subtract 2i square roots of 2 over 2. And that simplifies to be -1 plus or minus I square roots of 2. Exactly the same answer. Some students like this approach because they can see how this denominator belongs to both of the terms in the numerator, and some students like the idea of factoring out a common factor and then reducing. So it would be good if you could be flexible and try both ways and see if you get the same answer. So you'll have some practice with this in the homework, and just know that if you haven't worked with I before, it can feel a little strange, but with a little bit of practice, you'll get used to using I just like you would any other number. Okay, so one property of real numbers that does not translate to a situation where you have a radicand, remember that's the piece under the radical sign. When you have radicands at a negative, you do not want to multiply -20 times -5 to be 100, because that answer would be 10, and that's incorrect here. What you want to do is you want to rewrite each radicand in terms of I. So that's right here. You want to write each radicand in terms of I before you perform any operation. So let's take a look at that. So what this means is that I'm going to take the square root of -20 and I'm going to write it as -1 times 20. And then the square root of -5 is -1 times 5. And now this radical symbol will go over each one of these factors. And now I can write the square root of -1 times the square root of -1 times the square root of 20 times the square root of 5. Now, since both of these numbers under the radical symbol are positive, you have the right to multiply them now using the properties of radicals, or exponents if you want. If you want to see the square root as the 1/2 power, so we get the square root of 100. And here we get I times I. So we get I squared times 10. Because the square root of 100 is 10. And recall from our work up here in D, I told you you'll be using this idea a lot. I squared is the same as -1. So this becomes -1 times 10, which is -10. So you'll have, again, some practice with homework for working with I, the number I, the letter I. All right, so let's take a look at a quadratic equation that does not have a real number solution or real numbers for its solution set. So just looking at this quadratic equation, you're saying, no, I'll just go about my business as I usually would. It's set equal to 0. So I can now identify the value for A, the value for B, and the value for C. Now you have some music playing and you just start doing the quadratic formula. Let's recall the quadratic formula again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, you are solving this equation with an equivalent equation. So you must have x equals as the very first step. From here, you can do all kind of equal signs, but this x has to appear here. Students just want to drop the x. Remember, you're solving this equation for x. So the opposite of b is going to be 8, since b is negative 8, plus or minus the square root of negative 8 squared. I have to put the negative 8 in parentheses, minus 4 times 3 times 7. The entire thing divided by 2a, which is 2 times 3. So this gives me 8 plus or minus the square root of 64, take away 84, all over 6. And this equals 8 plus or minus the square root of negative 20, all over 6. So the minute you see the negative 20 under that radical sign, you know that I is going to be part of your solution. So again, if you recall how to simplify the square root of 20, then the square root of negative 20 will be the same answer with an I as a factor. So let's take a look at that. This is going to be the square root of 1, negative 1, times the square root of 20 all over 6. So this is 8 plus or minus I times the square root of 20 all over 6. And that equals 8 plus or minus I. Now let's simplify the square root of 20. So the largest perfect square, the number that's a perfect square that divides into 20 evenly, is 4. So I'm going to say square root of 4 times square root of 5 all over 6. So that gives me 8 plus or minus I times 2 times the square root of 5 all over 6. So now I'm going to write A equals 8 plus or minus, I'm just going to put the 2 in front of the I, all over 6. So you can reduce this because each one of your terms, the 8 and 2i square roots of 5 and 6, have a factor of 2 that's common. So one of the ways you can do this is to factor out the 2, and you have 4 plus or minus I square roots of 5 all over 2 times 3. You can cancel out the 1, 2 over 2, and your answer is 4 plus or minus I square roots of 5 over 3. So your solution set would look like this if you were to write it using your homework. The smaller number is 4 take away I square roots of 5 all over 3, comma, 4 plus I square roots of 5 all over 3. So that's one way you can simplify that. Again, remember your other way is to say x equals, and now you take the 6 and you write it underneath as the denominator for each of the 2 terms in the numerator. And that equals 4 over 3 plus or minus I square roots of 5 over 3 when you reduce each of these fractions. And now you smush them back together again because they have common denominators. 4 plus or minus I square roots of 5 all over 3. So you pick whatever way you like to simplify your quadratic formula. So if you have any questions, don't forget you can always send me an email. Okay, good luck. Have fun.